Tradewinds is a machine learning operations company focused on providing machine learning operations tooling along with mission-focused solutions to meet a wide range of data processing needs. Dynamic logistics planning requires an up-to-date understanding of the physical infrastructure that enables the movement of resources or supplies to meet the needs of joint staff, commands, service components, and downtrace unit logisticians. The volume and scale of data required to maintain a robust awareness of the health and status of logistics assets requires the use of automated data processing tools, such as computer vision models. Often, these capabilities are developed as point-in-time solutions that are not easily adapted to meet changing operational realities. SkySaver is a machine learning operations platform for tasking, collection, processing, exploitation, and dissemination of remote sensing data, which can include satellite, optical, and synthetic aperture radar imagery, sensor and imagery data from unmanned platforms, fixed camera systems, AIS, and radio frequency data to support indicators and warnings and domain awareness tasks. By customizing the machine learning models and analytics underlying SkySaver, the application can support providing near real-time health and status for the nodes and modes that make up a sustainment network and update the data with the required ontology in Maven Smart Systems via machine-to-machine integrations. SkySaver provides a no-code user interface to orchestrate persistent monitoring workflows and maintain an up-to-date awareness of sustainment network assets and other objects of interest. The application allows users to define areas of interest to monitor and review what locations are being actively watched. Out of the box, SkySaver has a direct integration with NGA's Global Enhanced Geo and Delivery platform and can also integrate data from any Open Geospatial Consortium compliant imagery provider and has previously integrated imagery for commercial providers such as Maxar, Planet Labs, and Capella Space. To define a new area to monitor, a user selects to add a new watchbox option, gives it a name, enters a brief description, selects the area they want to monitor, selects the imagery provider, and underlying analytics that they want to run against this imagery. Once the user submits a request, SkySaver will handle spinning up the right resources, pulling the imagery, and making the inference request to the underlying Chariot machine learning operations platform. Detected objects of interest are overlaid in SkySaver for further review. Users can then manually or automatically export the detected object to Maven Smart Systems. Here, we can see SkySaver making the image request to the image provider in real time and also queuing up modeling resources to the Chariot machine learning operations platform. To review the outputs of a previously executed run, we can see that once the imagery is provided to the Chariot platform, the imagery is analyzed and the detections return back to the SkySaver user interface. Users can interact with the outputs of these models and also give feedback to make sure that the models are performant or adapting to any operational requirements. In this case, selecting this particular detection, I can verify that it is indeed a ship and also indicate places where the model has missed. This feedback is directly sent back to Chariot, and this model improves performance over time. The exact same result can be orchestrated for any model looking for logistics assets, such as these ports or other infrastructure that's available in this imagery. SkySaver's integration with the Chariot machine learning operations platform means that the required analytics to monitor sustainment network nodes and modes can quickly be built and integrated into SkySaver workflows. In this example, we have unannotated imagery that contains logistics assets of interest. By annotating this imagery, we can quickly build up a dataset by which to train a model that will then be able to detect these images and new unprocessed imagery. This dataset will form the foundation by which we will train the required analytics and continuously monitor these logistics nodes and mode assets. Object detection and segmentation models are supported. In this example, I will use a pre-processing algorithm to quickly parse out the relevant assets for the sustainment model. SkySaver's open architecture allows it to quickly integrate and disseminate information to downstream systems, such as Maven Smart System, with the right ontology for each of the detected objects. It also allows it to quickly integrate with additional logistics supply chain workflow tools, such as Govini's ARC platform.